3 monitors at the moment. So taking advantage
Okay.
of this.
Yes. Oh, she's taking the blooming charger. All right. Okay. Fair enough. Yeah. Okay. Yeah. So I'm sort of fairly ready to go. I don't know what the time is. What is the time?
It's 2 minutes. We're 2 minutes early. We can't go yet. We can't go yet. We can't go. We can't go.
Yeah, we ruin our reputation.
No.
How was your day? Okay, so where are we? Yeah, okay, so we're going to be doing inspection testing, the missing tests.
Yes.
Is everybody in?
I think. Yeah. I mean, more have registered than is in here, but I think it's nearly 1:15. So let's just push on.
We'll just crack on, and we're going to try and keep this to 3/4 an hour.
Yeah. So hello everyone. Happy 8:15 webinar. We're rerunning a couple of our older webinars for guys who obviously couldn't hit those times. We are trying to get back in the flow of doing webinars. We've had a few weeks absence from this. We've got new webinars coming as well. I think the first new one, or one we haven't covered yet, is Saturday morning.
Yeah.
On the electricity work regulations. But yeah, thanks for coming in. If you guys have done this before, you know that there's you can chat. You should be able to chat with each other as well. I'll just check that. It looks like that's on. Do questions and stuff. Interact, engage. This webinar, there's one that Phil wrote. Just really talk about the tests and some of the and really he's focusing on the tests that we should be thinking about doing in comparison to the tests that we focus on doing, and also the tests that we record. And he's got some tests that he wants to talk about. So I'll hand it.
Indeed. Okay. Right. Good evening, ladies and gentlemen. Right. Okay. Yeah. The missing test. What we're looking at here is when we ran this before. What was encouraging was that a lot of you guys are actually doing the tests that we're talking about. And when you look through the schedule of tests as quoted in the on-site guide and guidance note 3, and the sort of things that get sort of taught in FE colleges and other training centres, they're missing out on some of what we think are some quite important tests. So what we're going to do with these is we're just going to highlight those. As I say, a lot of you will probably be doing these anyway, because you guys know what you're doing, and you're fairly experienced. So, but if there is anything here that you think, oh yeah, that's quite new, by all means throw stuff through to us on chat or Q&A. Yeah. But
it's probably important for me just to add that whilst we do training, these aren't additions that we think theoretically should be introduced. We also are on the tools and
we do them
in the workplace. Yeah. And so the reasons that these are up here is because we find that in the workplace that doing those tests gives us much more information and actually gives the client a lot more awareness of risk. And each of the tests, we will have a reference to when we've done that and we've seen that. So these tests that we're talking about are because of experience.
Yeah.
I think that's fair to say, isn't it?
Yeah. They've helped us to find and analyze and sort out faults and possible failures and dangerous situations in installations, and this is why we suggest them. It's not just sort of let's do it just for giggles. Okay, so we'll just have a look at what we're looking at. So we're looking at the tests and records also that we miss from the normal sequence of testing as per the on-site guide and guidance note 3. We're going to run through the sequence of tests. If you've got a guidance note 3 with you, the letters, or numbers, as you can see on the slide, relate to the actual section in guidance note 3. If you haven't got guidance note 3, it's not greatly important, but if you have got that, you can actually use that to just refer to the slides. So from guidance note 3, continuity of protected conductors, including main and supplementary bonding. All right, this is always the sort of starting point when we start to test, and we're looking at making sure we got the main earth, make sure we got main bonding, and making sure that we've got the protected conductors for all our radial circuits, and also supplementary bonding as and where it's needed. So with guidance note 3, it recommends that we test from end to end. This is for your main bonds and your main earth, okay, using method 2. This is a suitable method of testing. Now, guidance note 3 gives a figure of your result should be about 0.05 ohms. Okay. Now, when we do the test, what result do we actually put down on the test sheet? Well, yes, we put a tick. Okay, so instead of actually putting a figure, we actually put a tick. 0.05 is the figure they tell us is the acceptable level, and we stick a tick in on the test sheet. So what does that mean to anybody? It just means it's there. Okay. As we've looked at before, you may have an earth conductor which is 1 meter long, and it goes into the wall, so you have to test it, or a bonding conductor, and it's say 1 meter long, so you test it because you can't see it throughout its whole journey. Now, a measurement of 0.05 on a 1 meter long bonding conductor actually shows that you've got a crap reading. So if it was 20 meters or 25 meters long, yeah, we might expect that sort of figure. But if you've only got 1 meter of cable, then you would expect something much, much less. So rather than just putting a measurement on it, put a test on it, and then saying, well, it's less than 0.05, we'll stick a tick in, what we're suggesting is we actually write the figure down. If you were then going back in a couple of years' time to do the test again, it may be rented accommodation or something else that might be needing to be tested fairly often. Okay, if you get a deterioration in your test value, then you know there's an issue. If you've got a cable which goes under the floor into the walls, you may have a connection in it. You don't know. And this is the trouble when we're doing EICRs especially. We're not going to start ripping floors up and carpets. All right, we're relying on the fact, or it says in the book we should have a continuous conductor. Yeah, we don't really know that if we haven't installed it and we can't see it. We're just hoping that it is a continuous conductor and there are no connections. There may well be a connection. And if we just put a tick in the book, all right, then we're not going to know. All right, it's less than 0.05, we'll put a tick in there. It's less than 0.05, we'll put a tick in there. Okay, whereas on day one it might have been 0.005, and on 2 years later it might actually be 0.4. It's actually much, much worse. But because we didn't put a test result in, we're not going to know that. So what we're suggesting is, and what we do, is we actually put the test result in there. We're taking the test, we're getting result, write it down. Don't just stick a tick in. As we mentioned, it totally disregards the length and the size of the conductor. If we know the length of the conductor, we can do a quick calculation where this is what it should be using the values in the back of the on-site guide or guidance note 3, and we can actually do a calculation. We should know roughly what the length of that conductor is and what the resistance is. So gauge your result and your calculation and make sure that they are about right. When we come on to doing continuity of protecting conductors, the final circuits, we commonly use the method 1, which is the R1, R2 method. Okay, absolutely nothing wrong with that. You can see why we do that. It's proving continuity of the CPC. It's also proving continuity of the line conductor. Again, we can do calculations. If we know roughly the length of the circuit and we know what size the cables are, we can do a calculation first, and then we can compare that with the actual measured result. If we don't do the calculation, if you just measure it, then you get a value. You stick that in the tables or stick that in your sheets, and it doesn't actually mean anything. So the actual calculation is important. Make sure you get that calculation done first. Again, using the data in the on-site guide or guidance note 3 in the tables at the back, we can do those calculations, and we should do those before we even start testing. So we have a whole range of values that we're looking for. Other things to consider is that if we've got metal conduit or metal trunking, we may have parallel pass through the metal containment. And there may also be parallel pass through supplementary and main bonding. Right? If we're doing a EIC, then yeah, hopefully we'll be removing those. If we're doing an EICR, that isn't always possible. So we always have to take that into consideration. Then according to guidance note 3, once we've bashed through the continuity of CPCs, for radial circuits, we rush on to do the continuity for ring final circuits. But we've forgotten something. There's another conductor that we haven't tested at all, the neutral. Okay? And for some reason or other, none of the schedules of testing in the guidance note 3, in the on-site guide, or any of the books, the textbooks that we use in FE colleges for teaching apprentices, any other books that we've ever read, none of them mention testing the neutral. So we've got a conductor there which is never tested, but it's an extremely important conductor because it carries current. If there's any breaks or any loose connections in the neutral, then we're going to have problems. A break in the neutral and the circuit is not going to work. Some part of the equipment is not going to work. If we've got loose connections, they can arc and cause a fire. So it's a very important conductor, and we must test it. So what we do is, once we've done our continuity of CPCs, doing our R1, R2 tests on our radial circuits, we will then do a R1, Rn test, line neutral. Exactly the same way, but instead of connecting the line and CPC, we connect the line and neutral together, and we do a result from there. Okay, and we record that on our test sheets. Where? Well, as you know, most of the test sheets don't have a box for that. So we've actually amended our test sheets, and we have a box for those R1, Rn tests. If you're using standard test sheets, what you can do, because the test sheet has 2 columns, for either using method 1 or method 2, when you're doing continuity of CPC. If you're doing method 1, R1, R2, you can put your R1, R2 value in there and then alter your R1 column to, sorry, your R2 column to R1, Rn. And that's what we do with the standard sheets. But on the sheets that we've actually drawn up for ourselves, our own adapted sheets, we've actually got a specific column for those. So if you're using standard sheets, you can alter that second column, the R2 column, and make it an R1, Rn column and put that value in there. It's a very important test and it needs to be done. If we don't do that, then we're going to have a conductor that's not been tested. Turn the circuit on, half the lights don't work, and it looks really bad. So by doing that test, we can prove the continuity of our neutral. We can also do further comparison with calculated values. If we know the length of the circuit, we can compare the R1, Rn value with our calculated value. It proves polarity on radial socket outlets. Okay, and it can also be used, again, quite importantly, for calculating volt drop. If we know what the design current for the circuit is, and we know what the R1, Rn value is, in other words, the resistance of the cables within that circuit, we can calculate the volt drop. So it's quite useful for that. As we mentioned, the standard test sheet can be adjusted for this. Just change the R2 column to an R1 plus Rn column and put your value in there. If we do not test the neutral, we also don't know that we are including all the conductors when we do an insulation resistance test. So by not testing the continuity of the neutral, there could be a break in the neutral. You do your insulation resistance test, oh, fantastic, all lovely. Then when you turn the circuit on, half the light's not working, for instance. Oh, there's a break in the neutral. And I've known people beforehand just go back and they'll sort of reconnect a light fitting. Oh, that's it, neutral's okay now. And turn the light circuit on, bang, because there's actually a fault further down the line, which they never tested because they had a broken neutral. So it's important that we've got this continuity of the neutral before we do the insulation resistance testing. Otherwise, we are not testing all the cables. Okay, so we then move on, having tested our neutral. So now we've done all our tests, continuity tests on our radial circuits. We move on to continuity of ring finals. And we do the end-to-ends, and we do the figure 8 tests. We test from line to CPC, and we test from line to neutral using the figure 8. Again, when we actually record the results on our test sheets, there is not a box for recording the line neutral R1 Rn value. So again, this is something that we think we should add in. So we've actually got a line neutral R1RN test value. We're going to take the value anyway, because we do the 3 steps. Having done the end-to-end, little r1, little rn, little r2, we will then do the figure 8 of your line and neutral, and we will take an r1rn value all around the circuit. So why not record it? Yeah, every test we take, we should record, and then we'll have something to compare with when we come back to do any ICR later on. So, having completed our continuity tests, we now go on to testing insulation resistance. And again, here is a test where we don't record all the values. The best way of testing insulation resistance is to have all the conductors terminated into the board. Okay? When you're doing continuity testing, it's better to have the cables out of the board. And this is quite often I say to guys that are doing new installs, yeah, don't connect the cables into the board until you've done your continuity tests. Once you've done your continuity tests, you can then put your cables in. It makes it much easier rather than putting them in, taking them out, wiggling them all around, doing all sorts of nonsense. So terminate your cables after you've done your continuity tests. Once those continuity tests are done, you then want to do an insulation resistance test. For that, we need the cables terminated into the board. And there's some really important reasons for this. If you've got all your CPCs connected in, yeah, and when you do your insulation resistance test, you will be testing all your live conductors or line conductors against all the CPCs of all circuits and all the extraneous and exposed conductive parts of the installation, because everything is connected into the MET. Right? By testing individual circuits, if you do an insulation resistance test on that, you may find you get a clear reading on that circuit, yeah, but your cables could be damaged elsewhere down the line and could be touching on another piece of metalwork, which is either part of another circuit or part of some containment system. Okay, so it's more important to have all the cables terminated into your MET, especially before you do insulation resistance testing. When we do insulation resistance testing, then we will tend to do a test between line and neutral. We'll do a test between line and earth, and we'll do a test between neutral and earth. If it's 3-phase, we will test between phases. When we look at the columns for insulation resistance, we've got two columns to record the values. So we record between live and live, which is line neutral, or between phases. Okay, and we record between live and earth, which is either line or line to earth or neutral to earth. And the books show us connecting the line and the neutral conductor together and testing to earth from there. Well, that's not normally how we're going to test. It's much better to have everything connected in at the board. So why not have a few more columns so we can actually record the test results for all the different tests we do. SELV and PELV circuits. Okay, SELV and PELV is a fairly common system. SELV systems or PELV systems, SELV lighting in bathrooms. Where on the forms is there a space for the test results that we obtain for a SELV system? Remember, with SELV or PELV, yeah, we need to be testing the extra low voltage side of the circuit as well as the low voltage side of the circuit. If it's SELV, we need to test the separation of the transformer. We're using a 500 volt insulation resistance test between the two sides of the transformer, or two sides of the circuits, the low voltage and the extra low voltage side of the circuit, and we're looking for 5 megohms, but there's nowhere to record that. So once again, the test sheets that we got are very, very limited. There's no space anywhere to record any tests for SELV systems.
We do find that that kind of results in the tests being abandoned.
Well, because they're not on the sheet, people don't do them.
No.
And this is one of the issues. Yeah. Earth fault loop impedance. two methods are prescribed. We can measure using a tester, or we can do a calculation of R1, R2 and add on the ZE. And there's arguments that have been made to say, well, we don't need to do the tests, and testing is dangerous because it's a live practice, and we don't need to do that. So let's ignore that, and let's just do an R1, R2 and add it on to our ZE and do our earth loop impedances by calculation.
Paul's actually just said that in the chat there, talk about missing tests. One of our contractors now wants to leave out live loop impedance testing as they want to reduce risk. To me, that's exactly the mentality the NIC placed a few years ago, where they started talking about light switches, and they were telling electricians not to do ZS tests on light circuits and to do R1, R2s and things because of electricity work regulation 14 and bollocks.
Yeah,
and people carry that over to anywhere they work, and they'll just not do live loop tests.
Yeah, and they're just basically short circuit. Well, you know, they're shortening the testing process. It's all about dumbing down, isn't it? It's all about minimum. Trying to what can we get away with and do the minimum all the time, and it just gets on my wick really, all that, because we should be doing the job properly. You know, we're qualified electricians. We know what we're doing. We're not stupid. We've been taught about inspection and testing. We should do it properly.
Well, it's the same thing where we've had this this attitude of, doesn't matter if your circuits are too long or your fault drop, just throw RCDs at it, because now the magic ZS value converts. You know, that's another thing, another seed that's been planted, and it encourages bad thinking.
It does indeed, as we shall see shortly. Yeah. The idea of just calculating ZS readings is extremely bad. Arguments have been made to support this, but no, we're electricians. Let's do a proper test. Okay. Now with socket outlets, I mean, it's like plugging a kettle in. So there's absolutely no excuse for socket outlets. If you're doing light fittings and stuff like that, then there are safe ways of doing it. There's adapters out there that you can use. There's all sorts of things that you can use to minimize the amount of access you need to take to actually live parts. But even if we do need to take a plate down to access live parts to do an earth loop impedance test, as qualified electricians, you know, we should be able to do that with a minimum of risk. At the end of the day, how are you going to get your ZE reading? Are you going to get your ZE reading by inquiry? You're going to ring up the local electricity board and say, what's my ZE? Because they're just going to give you a bog standard number. 0.35 if it's TNCS, or 0.8 if it's TNS. You know, they're going to give you a bog standard number. The only way of getting a proper ZE is to actually measure it. So if you're measuring it, you're going to do a live test. So if you can do it there at the fuse board, so why can't you do it at a light fitting? It's, you know, to me it doesn't make sense. Well, it's okay to do it here, but it's not okay to do it there. It's nonsense. So yeah, when we come to do an earth loop impedance, we need to do the test properly. By testing at the end of the circuits, we get a proper reading at the points of use.
So I'll throw this spanner in here then. Why is it worded that it could be obtained by calculation?
Okay.
My opinion is for design.
And that's it. You know, if you're doing a design for an installation, the only way of getting your ZE, okay, if it's not built yet, is to inquire to the local authority, the DNO.
And the ZS is by calculating.
Get your method by ZE. Then you do your R1, R2 calculations by knowing how long your circuits are. You can measure those off your drawing. So you can do your R1, R2 calculations. You take your R1, R2 calculation value, add it onto your ZE by inquiry value, and that is your calculated ZS. When you're doing a new installation, before the supply comes in, the DNO, this is what used to happen when we used to do new stuff. The DNO would not give you a supply until they saw a certificate hanging on the fuse board. Okay, once that certificate was there to show that you've done the dead tests, you've done all the inspections, and you've done the dead tests, and you've done your calculations showing your earth loops, yeah, we're all okay, the DNO would look at that and think, right, great, no problem at all. This person knows what they're talking about, and they'd give you a supply. They wouldn't give you a supply until they saw that certificate. And so by calculation and by inquiry is all about getting that paperwork together at the design stage and before you've got a supply.
It does say, can't remember where exactly it says it, but it says the supply authority may, will need to obviously get evidence of the safety of the installation to continue or, provide a supply.
Yeah.
And if it is unsafe, they actually may be put in that position of having to actually remove the supply.
Or they might not give it to you.
I'm trying to remember exactly where I saw that.
Yeah. Yeah, I mean, going strictly from, I mean, I've read it in one of the recent documents saying that the DNO are not obliged to give you a supply unless you can prove that the system you put in is safe. So, and that's what that's for. So when we're doing earth loop readings, let's get the tester out and do the job properly.
Mm-hmm. Mm-hmm.
Earth loop 3-phase. When we do 3-phase measurements, we've only got one box. Okay, so for a 3-phase circuit, okay, we've only got the one box. Let's record all of them. Let's make sure that all 3 phases we've got a decent earth loop for, and they're all pretty much the same. If you leave 3 lines on your certificate, which a lot of people do, they leave three lines for a 3-phase circuit, you can actually record each of the 3 earth loop values on each of the individual rows. But yeah,
and different software handles that differently as well, because you have to call it a single phase or a TP for 3 phase, then it'll adjust it. But some actually does restrict you; it doesn't even allow you to do that.
Yeah.
I remember when I used to use Amtech. I hate Amtech now because their software was broken when I used it, and I lost 30 odd hours of work. But you couldn't put in that a device was a type B. You couldn't put in that the device was a B type with a 10 kA braking capacity. The software just said those 2 things don't coexist, and you couldn't even overhaul it when I was using it. This is a couple of years ago now.
Yeah.
It was very limited what you could do.
And that's the trouble with any software, or most software, say any software packages, or most software packages, you are limited to what you can do and how you can adjust it. The thing about inspection and testing, the thing about electrical work generally, is the fact that we've got to be fairly dynamic, and we've quite often have got to assess risks and write things down and report on things in our own way, depending on the environment and what we find and the utilization of the building and all sorts of other things. Okay, it's not like a standard electrical system. This is an electrical system, and it's got to be this. It could be a school, it could be an industrial complex, it could be a home, it could be all sorts of things. And whoever's using it in different environments and different utilizations will change, what your requirements are and what you will allow.
I mean, go back to what you said earlier on about the bonding. We talk about 0.05 as the example that it uses with sizes of cables, but if we don't have a numerical value, many sites will have earthing and bonding in particular that is actually quite exposed to damage.
Yeah.
Obviously, I'm working on a railway right now, and lots of it relies heavily on bonding everywhere, and lots of it is easily damaged, and so we're having to measure it to verify it. And if we don't actually have a value to request, you're going to then rely on. If you're not going to rely on being able to test it, you're going to have to look for it, and a lot of the times you can't look at it all.
Yeah,
especially when some of it gets stolen, from underneath the platforms, where you don't send people to inspect all the time.
Yeah.
So you have to have values to go, oh, that's suddenly disappeared, or that's gone up in resistance.
Yeah, and as I said, I mean, 0.05 for 2 meters of 10 mil is a crap reading. It's a really poor reading. So why would we accept it? It doesn't make sense to me.
Going back to this ZS, I mean, it might seem weird, because a ZS should be the same for all 3 phases, but you can get information. If you see, let's say, one of the phases of slightly increased resistance, and then at the subsequent next in EICR, you see a further increase, you're picking up a deterioration which is starting to progress.
Yeah, and what's going to cause a high resistance? What's going to cause a high resistance? Yeah,
because otherwise we should only have one value and accept one value, which is the same value. If we have different values, we should record them so we can see the different changes. And from the temporary event industry, we pick up a lot of faults by seeing the different phase values.
Yeah. Remember that the thing that causes a lot of higher resistance values would be a loose connection. So if you've got 3 phases and 2 of them are, say, 0.08 and one of them's 0.16, you think, oh, hang on, there's an issue there. So, every test reading you take, every test result you take needs to be analysed, and you need to look at it, and you need to think, okay, what's that all about?
We had one 2 weeks ago. It was actually the 3-phase breaker. One of the phases in the breaker had a high resistance to it.
Yeah. Yeah, the actual breaker itself, and that again is an issue, because
just traced it all
you
the way
get this
through.
sometimes. You get these rogue things that happen within the actual breaker contacts themselves. Okay, so it's okay. Let's ditch that breaker. Let's replace it. Get a new one. Okay, so yeah, 3-phase earth loop impedance. Let's record all the values. Let's get all those results that we record, the results that we take, write them down. They're important bits of information, and it helps you to assess and analyze the quality of the actual electrical installation that you're dealing with. Prospective fault current. Here we go. Okay, so regulation 4341. The PFC should be determined at every relevant point in the circuit. And in practice, what we're told and what's bashed into us at college and in our apprenticeships is check it at the origin and check it at your fuse boards, because what we don't want is such a high fault current that it's going to blow your protective devices to bits. This is the emphasis all the time, isn't it?
Yeah. The common worry is the current sufficient to operate the device in a rate which will not break the device?
Yeah.
Breaking capacities. Yeah. And that's where it stops most of the time.
That is it. That is the emphasis all the time on prospective fault current.
Yeah.
Is it too high? If it's too high, you need to put a different type of protective device in there. And that's why we quite often find in switch rooms, we might have BS88 fuses or MCCBs. Whereas a standard MCB, you're looking at a maximum probably of about 10 Ka. So you're looking at MCCBs and of sort of 25 Ka, you're looking at HRC fuses between 56 and 80 Ka. So when you've got these really high levels of fault current, which you'll have if you've got a really big cable coming into an installation, if it's got a large load, you'll have a really big cable coming in. If it's close to the local transformer, you can have fault currents of 30 Ka or more. Okay, and obviously, yeah, your standard 10 Ka MCB is not going to take that. It's going to just disintegrate and flow across the room. So this is the emphasis all the time when we're looking at fault current, is measure it at the origin, measure it at your fuse boards, okay, and then just keep measuring it at other fuse boards until it diminishes, because the more cable we've got going in on distribution circuits and stuff like that onto subsequent fuse boards, eventually that level of fault current will diminish to a level where we don't need to worry about it anymore, because it's now low enough to not cause any damage to our circuit breakers. Okay, and that's always been the emphasis on fault current. And this is something that we picked up when we were doing temporaries, because in temporary situations, we have, with temporary events, we have cables that are so long, circuits that are so long, we have the other problem, which is there's not enough fault current to actually operate the device. And this is why we we were testing at the end of circuits on temporary systems. And because of our experience with doing that, we started thinking about fixed installations and thinking, well, what about fixed installations? Do we ever have circuits there that are so long that the impedance at the end of the circuit is such that we don't get enough fault current to operate the device? And especially with RCDs, the RCDs, these wonderful, wonderful RCDs that do everything for us. Remember, they don't protect against overcurrent in overload or short circuit. They only give you earth fault protection. They'll only detect an imbalance between the line and neutral, which is normally an earth fault. So if you've got a short circuit or an overload, they're going to do nothing.
Yeah. And the thing is, I mean, we have a lot of installations where we'll have, you'll have RKBs go in those types, then we go to type Cs and those types, but we'll have a lot of installations where there'll be a breaker that might be, a type C, where it's put onto a circuit that isn't just a supply to a motor or supply to a fan or supply to a thing, but it's actually a long radial circuit, which is a scenario that we had. So it was, I don't know, the length of that circuit must have been, what would you say, about 40 meters maybe?
You're about the one on 5?
Yeah.
Yeah, I'll get probably about 40, 45 meters long, yeah.
I mean, that's not substantially long, but when it's having to be protected by a 320 amp current, clearly it was long enough to give us not enough current.
Yeah. I think on that one we measured some of the reason we measured such a high fault, or such a low fault current. The earth fault was fairly high, but it had an RCBO on it, and that was okay, fantastic.
Well,
We've got an RCBO.
Then the earth fault was supported by parallel paths of the wiring system.
Yeah, but then the short circuit current was somewhere in the region. I think it was about 80. No, it's about 180 amps, wasn't it?
190, I think.
190 amps. Yeah, and because it was a Type C device, it needed 320. And when we did the time, the calculation, the adiabatic equation, and worked out the time it took for the actual device to operate, we were looking at somewhere in the region of about 12 to 14 seconds. And then when we did the cable sort of calculation for temperature, it would have overheated in 8 seconds. So, yeah.
And as we discovered in 7909, 7909 has a model form for testing, and it has a column for the is it called PSCC in the column?
PSCC, yeah.
The short circuit current in the column. And we kind of went, oh, that makes sense because of the length. But then when you're in the fixed installation, that is also very relative. And we think that should definitely be a column here.
Yeah. So, as I say, we have now for a number of years been testing fault current, short circuit current, that is, at the end of circuits. And that's all because we came across this in temporary installations. And we have found quite a few circuits in fixed installations that do not comply. Under short circuit conditions, we will have a situation where the cable will overheat. Now, whether it will actually catch fire, maybe not, but it will certainly get heated to an excess and cause damage to the cable. And that's just due to either having the wrong size cables installed, okay, or having cables that are too long. So poor design. And unfortunately, everybody's emphasis has been on earth fault. And with the advent of RCBOs and RCDs, people forget about short circuit. Now, if you remember, we're talking about protection for safety. All right, 41 is all about electric shock. 42 is thermal effects.
It seems to me like BS7671 spends so much effort and time putting 41 across that we kind of, when we get to 42, 43, 44, that we kind of just skip through it. I mean, I've seen companies doing training that has so much effort, maybe 2 or 3 slides on 41 instead of the 50 I have. But then 42, 43, and 44 are just, oh yeah, there's fire, there's overcurrent, and there's, you know, they just don't put, and for a lot of electricians, they just don't develop the same understanding. And it's still tough now. I mean, we're trying to do a lot of work right now on over voltage, you know, 44, but 43 overcurrent and the impedances, and 42 thermal effects, it's all here. And this particular test, short circuit current tests, is important for both.
And it's such an easy test because when you're doing your earth fault loop impedance test, most testers now, you can just change the selector switch to line neutral and it will do your short circuit current for you. Okay, so it's another good reason for doing proper earth loop impedance testing. Yeah. Because by having done the earth loop impedance test, we can just change the setting on the tester and we can now do a short circuit test. Yeah, and it is so useful. And we have come across so many instances now of cables or circuits that are incorrectly installed and could be a fire risk in the event of a fault. Especially, we get this, and we've seen it time, I expect most of you guys have seen it. You go to a fuse board and it's got a type D circuit breaker on a standard circuit, and you think, well, why have they installed that? And it's possibly because that's all they had in the van at the time. And you get these people that will just bang it in and think, well, that'll do.
It stopped tripping then, didn't it?
Yeah. I'll pop back and I'll change that sometime when I'm passing, you know, and they never come back. So you find type D circuit breakers installed in domestic dwellings, and you think, well, what is that about? Remember that a type D needs 20 times the nominal current to actually trip, whereas, you know, type B you're looking at 5 times. So a 10 amp type B will require 50 amps fault current to trip it. A type C is 10 times. Type D 20 times. So a 10 amp breaker needs 200 amps to go through it before it'll actually trip within the required time. So, you know, I don't like to see type D breakers. Yeah, they're a big folly. But we come across them, you know, occasionally.
When I see them, I basically have to stand back and have unless the specific item of equipment says no, it's got to be a D due to obviously its behaviour.
If it's a heavy motor, if it's a welder or something like that, then yeah, fine.
Unless it's obvious. Otherwise, I would really step back and actually determine
But then, even then, you see, when you're feeding a big heavy motor or a welder or something in that sort of description that needs a Type D, then the cables would have been selected accordingly. So you've got larger size cables, you know. So if the design's been done properly, that's no problem. It's when people just willy-nilly just chuck a Type D in because that's all they got in the van. You know, I'll just throw that in and hope for the best, and I'll come back later, and then they never do. So overcurrent protection, when we're looking at the operation of overcurrent protection, remember that RCDs, RCBOs do not give you short circuit protection. Oh, sorry, RCBOs will. RCDs don't. They don't give you short circuit protection. They're about as much use as a chocolate teapot. And we rely too heavily on RCDs to protect us against everything. The reg says that under fault conditions, most final circuits should disconnect within 0.4 seconds, depending on the type of earthing system, etc. To achieve this, the MCBs require a certain amount of current to flow through them. Okay, and as I've already mentioned, a Type B requires 5 times the nominal current, Type C 10 times, Type D 20 times. So a 32 amp Type Type C requires 320 amps fault current for it to flow before it will actually trip within a given time. If you don't get 320 amps fault current, so when you do your prospective fault current test, if your fault current is less than that on a Type C 32 amp MCB, you know there's an issue. What you do then is you look at your thermal withstand calculation, you can do your calculation and see how bad the problem is. You might find that it's still okay, that the cable will still take the temperature and it will still be okay, and it will disconnect before the cable gets damaged. But quite often you'll find it's not. So it's a bit of an issue. What can we do about it? Change the type of breaker if we can, if it's the right type of circuit. If not, then it needs to be a case of the cables need changing. So it is a big issue, and it is something that we're picking up more and more and more, because for too long now we've relied too heavily on RCDs to protect us against everything. Okay, so as we said, many circuits don't have sufficient prospective short circuit current. Remember, this is line to neutral, to actually stop the cable from overheating, and in some cases this could cause fires. And let's face it, there's more people die from fires than there is that die from electric shock. So fire is a big risk, and we need to sort of wake up to that idea. And electrical systems do cause an awful lot of fires. Other tests that we do that we don't actually record properly. Phase sequence testing, we put a tick. Now, phase sequence testing, it's all about, with a phase sequence test, is the phase sequence maintained throughout the installation? So we would normally expect to see the phase sequence of 1, 2, 3, and we would hope to maintain that throughout the system. Now, if you go to a building and it's 3, 2, 1, okay, then we don't do anything about that. We just make sure it's 3, 2, 1 at every relevant point. All 3-phase fuse boards, all 3-phase socket outlets, isolators, and so forth. We check the phase sequence. Is it still 3, 2, 1? As long as it is, then phase sequence has been maintained, and according to the test sheet, we put a tick. Now, wouldn't it be better to actually write the phase sequence down? Record the phase sequence. It's 1, 3, 2, it's 3, 2, 1, whatever it is. Okay, then people will know what the phase sequence is, and we can make sure it's maintained.
You kind of get the feeling that the fewer tests that are acknowledged or confirmed with a tick, the better. This is an issue that this is an issue that we're currently having with a maintenance project, where the maintenance company just puts their initials under things, and that doesn't give us a determination of risk. Is it good? Is it bad? It's not a code. It doesn't, just saying the initials doesn't mean it's been completed. And they just said, it means they've checked it.
Yeah.
But it doesn't give us any understanding of its value or its condition or its state.
Yeah, people are very quick to put ticks in.
This just takes us down to the further need for us to be able to do these things in 20 minutes. Which we'll discuss in our webinar a week Saturday.
Yeah,
we're going to basically just moan about the ICRs and the new legislation, so we'll save all that for then.
I did an EICR the other day. Last week, actually, I got called out to do an EICR in Windsor. And I think I was there for about it was a 4-bedroom house, over 3 floors. I was there for about 3.5 to 4 hours. The house was empty.
Oh, empty property.
Yeah. And I was still there for 3.5 to 4 hours by the time I'd sort of got there and got away. And then I spent a couple of hours actually putting the report together and writing it all up. So
Did you get your tools out? That's the key.
I've got tools out and got testers out, mate. I actually got them out and working.
Well done.
So anybody that says they can do that for 70 quid, yeah, well, good luck to that, because I can't work for that sort of money. You know,
no, we're gonna pick this. We are gonna pick this up in the upcoming webinar.
It's the race to the bottom, isn't it? It really is the race to the bottom. All that. Anyway, we digress. Operation of RCDs. Where do we record the rating, the RCBO, and the tripping time? At ×5. That was another thing that's been changed and altered, isn't it? We've sort of lost that that column.
It's annoying because the AFDD column. I mean, the AFDD are right. The manufacturers are basically kicking companies right now swiftly in the dick for not embracing AFDDs enough, because people aren't putting AFDDs through. They're not being sold, understandably, I guess. So that column is right. It's a waste of space, and even that, that column just no. The RCD column ×1 ×5. People still get confused by it. And I've heard people give different advice on it as well. So,
but the other thing is, if we don't put the rating the RCD in, it's meaningless anyway. You know, what rating is the RCD?
I said to you,
is it instantaneous? Is it time delayed?
As I said to you before this webinar, because we actually talk electrics sometimes when we're not live as well.
Boring old farts, aren't we?
I think there should be like a separate little thing about RCD use, so that the electrician who comes to this installation can now know, right, this RCD is used for the purpose of fault protection. This RCD is used for the purpose of additional protection. And then as soon as they know that, they can go, right, well, the one that's there for additional protection should also be verified for ×5.
Yeah.
Yeah. And if the RCD is not there for that purpose, then that is not needed. Just a way to easily determine why the RCD has been selected, so we then know how to verify it. It doesn't tell us what it's selected for when we just put there's an RCD. No,
and as we were talking about earlier, because I've been working on the inspection and testing sheet today, rejigging it again. We need to know what circuits are doing. So we need to know what type of RCD we can use, because we've got type A, type AC, type B, type F. Unless we know what they're actually protecting, what's in the circuit they're protecting, we don't know whether or not we got the right type of RCD.
Yeah.
We could put an RCD in and test it to the end of its life, but unless we've actually got the equipment connected, we don't really know whether it's going to work under use.
And subsequently, if you're an electrician doing an EICR today, let's say an electrician tested this installation 5 years ago, and it was satisfactory. In 5 years, the user of the installation could have bought new products.
Washing machine.
Many of those products could now have gone, oh, we don't like those ACR CDs. We want type A. So we now have to actually think about looking at the equipment. We didn't really have to do that to this degree. But now so there's going to be a new inspection at some point to verify that the type of RCDs are still suitable over time.
That's what I'm now including on my inspection sheet. I've actually amended it today, so I've actually got four different boxes for the 4 different types of RCD, and so when I'm doing my inspection, I've got to verify the type of equipment that's in the installation to the best of my ability, and then obviously there'll be an assessment, a risk assessment that gets attached to it. And this is the sort of thing that, because technology is changing and because people are buying equipment that's now causing problems with our electrical installations, we as the electrician have got to get on top of this, and we've got to make those calls. And that comes back again to this business, these people doing these things for 70 quid. It's nonsense.
I still strongly think that we're going to end up in the next 10 years or so, we're going to have to develop, because with smart homes coming in as well, there's a mention of a manual in Guidance Notes 3, the operator user manual. That's actually, we don't physically create that for domestic installations necessarily. We might put the EIC on the side next to the gas certificate, so the landlord or tenant has the paperwork. We don't really, or maybe the instructions to the boiler, but we don't really say, right, well, here's the manufacturer's instructions for X, Y, Z items of equipment, maybe a drawing of the routing of the wiring system in the walls. We could do so much more if we weren't struggling to get the work in because of the pricing and all that other shit.
Well, this is always the issue, isn't it? And you know, for places that we've installed, when we've done rewires and stuff like that in the past, we always used to put a little folder together with all the manufacturer's instructions in there of all the different bits of kit. The outside lights for the photocells, the bathroom fan, all the bits and pieces, all the information used to go in there, and then we used to run the customer through setting up the bathroom fan timer and this, that, and the other, so they knew how to do stuff and they knew how to adjust things, the photocells and stuff like that. And we used to do that with the customer, and it's a bit of sort of like commissioning and stuff like that, and used to have to spend time to do that. You know, but that all takes time and it all takes effort, and
It does take time.
you know, it's just unfortunate that it is the race to the bottom. People are just sort of charging in.
Again, the job is done when the numbers are put on the paper. Once the number is done, you know, once the numbers are on the paper, then due diligence is done in the eyes of the idiots, and they move on to the next job.
Well, I mean, I think there should be somewhere on the forms that you've actually signed it over and you've commissioned it and you've explained the things to the customer as well, and get the customer to sign it, say they're happy with it.
There's a number of things we can do to improve that bit.
Yeah. Okay, so yeah, functional testing, recording functional testing. We've got a column, haven't we, for functional testing, where that is now put aside for RCDs. What about functional testing of MCBs, isolators, and switches, and all the rest of it? All these other bits and pieces that we need to check the functional switching of, and yet there's not a column.
See, I found this is where our guys who do AM2 fail. Because we go to work and we go, do your functional, and all that means on the job is on the RCD. When functionality actually is every single device, accessory switch, time switch, clock, anything has to be verified for functionality.
Even MCBs, we should be testing the MCBs. We should make sure they make and break. And we can do that with continuity tester when we're doing our continuity testing right at the beginning. We should run all the way through the fuse board, make and break, make sure they actually do that. Because you know yourself, how many times have you taken an MCB out of the box, brand new, and it doesn't actually make or break, one of the two? It's surprising how many are faulty. So again, functional testing, there is no space for it on our test sheet. We need to have a column there for functional testing of all these pieces, you know, MCBs, switches, functional switches, isolators, and all the rest of it. Not just the RCDs. So there are a number of tests that should be carried out, as we can see, to prove the installation has been completed safely, and they're simply missing. And the primary ones, you know, from our point of view, are things like prospective short circuit current. That is really important, and testing of neutrals. I believe some companies have listened and have learned. I know the one that is often mentioned is elective form. I think they are always trying to evolve the certification. They listen to electricians, and a lot of electricians give them feedback. It's a shame that BS 7671 isn't going to listen to electricians, but fuck it. At the end of the day, you know, this is the minimum requirement, and you know, go to town with it. As long as the minimum is there, give the rest. This is the big issue, isn't it? So yeah, we've got a number of tests that should be done, a number of inspections and stuff that we should be doing, and lots and lots and lots of test results that we take, but we don't bother recording, and would be really important and really useful if we're going back to do an EICR. And now that these landlords inspection and test things are coming in, way beyond time, but and probably not being done the way that I'd like it to be done, but they are at least coming in, and this is really important, so we can see how installations deteriorate over a period of time. And the more information we've got, the more test results we've got to gauge that by, the better it is. I did a video on YouTube over a year ago where this legislation was finally announced in Parliament, and I talked through the spoken word in Parliament, and I looked at what they were trying to achieve, and I summarised the video to say, you know, this could be a new little register, this could be a new little strategy, and most of what I've said would happen has happened, and unfortunately, it does mean that more of this work is going to be done
And when there's more something to be done, they'll find ways to do it easier and quicker. This isn't, you know, this new legislation is not going to improve EICRs. That's for sure.
No, it's
not
not
going to improve them.
No, because we've already seen it, haven't we? We've already seen people bashing them out for, you know, book a 2-hour slot or book a 3-hour slot, and we can do it for 70 quid. And it's total nonsense. It's absolute nonsense. You cannot do an EICR on a typical 3-bedroom semi, you know, within, you know, 2 hours, or it's nonsense. You can't do it.
It is a nonsense, but again, I've said this in the podcast with E5. Every single one of these documents needs to have a traceable number, and that number must be linked to a person who's been authorized to do that work, and the paperwork should be sent to a system that they can actually sample. If I run a company, I'd have something like software, like a bit like Ryan's software TCW, and everyone who did a certificate before they submitted it would have that run through. And it'd help them improve. But if anything comes through that flags that, oh no, this guy's registered 8 jobs today, flag it. Just by, well, he has actually himself signed 8 jobs at this address, this address, this address, this address. I would immediately check his previous month's work to see how many he's done, you know, and I'd send someone. And if he's being a dick, I'd take the license away, or I'd sanction it.
Yeah,
you know, and it's easy, it's autonomous. It's just they're not doing it. They're not doing it.
It is a weird and strange and crazy thing that you know, and I've likened this before to, if you take your car down the garage for an MOT, right? If the garage just kicked the tyres and said, yeah, that's all right, you wouldn't be
happy
too happy
because you had to get an MOT.
You know, your car's passed. Are you going to be happy that your car has passed and it's only cost you 40 quid? Or are you going to be slightly doubtful and worried about the fact that you're off on holiday the next day with your wife and kids, and you're travelling sort of 600 miles in your car, and somebody has gauged the safety of your car just by kicking the tyres,
a lot of landlords
saying, yeah, that's okay. Well,
That's
this is the issue, isn't it? We've got to make them care, and we've got to make people sit up and take notice, because this is what's happening with the whole of this thing. It's very much the same thing. You know, the idea of going in and spending 2 hours or less than 2 hours or 70 quid on doing an EICR is equivalent of just kicking your 4 tyres on a car and saying it's okay. You know, and it's just not good enough.
Right. Is there anything else on this presentation? Or
no, I've finished prattling on. So, yeah.
Right. Awesome. Okay, I'm going to go to the questions and I'll jump into the chat. So, David says, volt drop verification.
Yeah.
Would it be acceptable to do a calc using little r1, little rn, volt drop using volt drop is equal to IB times R1 RN times 1.2?
Yeah. Yeah, basically it would be, because the R1 RN is the resistance of your cable under
your circuit impedance.
Circuit impedance under test sort of conditions, i.e. when it's cold.
Your test conditions are cold conditions, and the 1.2 obviously
1.2 for the increase in temperature for when it's under use. Yeah, and then obviously your design current.
The only thing I would say to that is a textbook alternative calculation that we've seen a few times. Now, what you do need to remember, though, is that is assuming 2 things. That is assuming that your test temperature is, you know, ambient or cool. And that's assuming that your load temperature is probably, you know, that 1.2 is assuming a specific travel of your temperature.
Yeah.
So if your loading is lower, it might be, or if the ambient temperature is a bit warmer, you've got solar loading, then you may have some discrepancy there. That is taking that to another level. But the factors are in the books.
At a very basic level, that's a good starting point. Yeah.
Indeed. Yeah.
If you find then you've got issues and your volt drops sort of on the cusp or just over, you may then have to look at your testing temperature and may have to make an adjustment for that, and the difference between your testing temperature and the maximum temperature of 70 degrees.
I mean, you can have a cable that's actually going through a very hot environment. You may have cables in direct sunlight.
Yeah, you might well be.
You know, your test would have increased to some degree, but you may be testing in the evening or at nighttime. Yeah. You know, this is something I have to worry about with thermal imaging, is obviously things like solar loading. If I do my test on a night shift and I've got a system that's cool and I say, oh, the volt drop is this, then when the sun goes onto that cable, it could load it, and that can severely compromise that.
I mean, unless you're testing in the midst of winter,
Mhm.
you know, at a very basic level, if you go by that, and if your values come within, you should be okay. Okay, but obviously if you're testing in the middle of winter, there might be some discrepancies. But any other time, yeah, I take that as a basic sort of yes, okay, that works.
So Sean says, how do we approach the subject of service rating values regarding PFCs of protected devices? Is this with regards to let through energy, or is this, because there's also talk about this in the chat. Not sure what the questions are asking for. I mean, just as a selection activity?
Service rated value.
Service rating value. Not sure. I'll pick up my Beamer guide and see if there's anything in there. But you just talk about the let through energy with that one. Let me know, Sean, exactly what you want me to answer with that one, buddy.
Bit more info on that one.
Bit more info on that one. I'll go to Paul's question then. So, right, measure PSCC.
Yep.
Check on graphs to see how long the overcurrent protected device will take to operate, then calculate how long the cable can take that current before it breaks down. So that's his question. Is that what we're doing when we did that earlier on?
Right. Effectively, when we take the fault current values,
end of line.
Yeah, we take the fault current at the end of the line.
Yeah.
If we can see from the rating of the protected device and the type, so if it's a type B 32 amp, yeah, we know that we're going to require 5 times that.
How do we know that?
Because that's what it needs, and you can get that from Appendix 3. You can either get it from Appendix 3, or you can get it from the tables in Part 4.
Yeah, it's in the Beamer guide. It's in Appendix 3, or the table again, as Phil says, in Part 4. In the table of ZSs in Part 4, there is a value to the very right hand, isn't it?
Yeah, it says times 5 for the type B, type times 10 for the type C.
I don't think you'll see it in a webcam here, but you're looking at this table, and there's an IN value here. And when you look at those, for type B, it's got 5 IN. For type C, it's got 10 IN. And, you know, so that's how we get those, you know, that's how we remember those multiples.
Or you go to Appendix 3 and they're in there as well.
But now
if
to actually,
Appendix 3.
But that's fine. So what we did is we did that to know there was an issue. But then, as you suggested, we then looked to the curves in Appendix 3 to find out where that value of current actually landed for time.
Yeah, so we see what the actual operating time of the actual device is, and then we do the adiabatic equation. T equals K squared S squared over I squared, which is in chapter 43. Okay, using the K factors from chapter 43.
Section 434, I think, which is fault current, isn't it? Okay,
then we can work out, T, which is the time, that it's going to take for the cable to reach its upper limit temperature. After that, you know, once that's reached that upper limit of temperature, if the device hasn't operated by then the cable is going to start to get affected. So it's obviously going to overheat. We're going to have a problem with the insulation, and effectively, if it doesn't get tripped out within a certain period of time, eventually it will catch fire. So as long as the time that we calculate by T equals K squared S squared over I squared, is longer than the operating time of the actual device, we're okay. So as long as the device operates before that time, we're okay.
People are going to bed now.
Yeah, I don't blame them. If not, then we've got an issue, and we have to take action. And that's when I would then put a code 2 under it, dangerous under fault.
Okay, another question. Back to functionality, where we talked about MCB functionality. This question popped up. How can we test an MCB to see if it trips safely?
With functionality, all you can do with an MCB is turn it on, turn it
manually.
Off. So you just do a functionality switch it on and off.
Continuity being made and broken is all we can really do.
Yeah, we can't
with the device.
Test.
We can't simulate a fault. That's not really good for the device.
Yeah, we can't test to see if it's tripping at the right time. All we can do with a functional test is switch it on and switch it off to make sure it makes some breaks. And that's as much as we can do from a functional test point of view.
Important to understand as well is like 62898 devices, they've got these little, I can't remember what they're called, these little flash cards inside them for, you know, short circuits, not overload, but short circuits. And if you have a short and you reset it, there's a huge amount of energy that's now been absorbed by that device to actually quench that fault. And if you then, so that's the first fault that actually operated it. If you then go to the breaker and there's a fault that you haven't noticed it's a fault because it's just tripped, you now go to reset it. And when you reset it, it goes, and it actually trips. That's now done twice. Yeah, it's recommended with majority of manufacturers that you don't keep doing that. You know, I've written rules, procedures, and standards where it's pretty much been agreed that you shouldn't keep doing that for a number of hours. I know one or two people even say 24 hours because it's got to actually, you know, it's been under a lot of stress. Yeah. So we've got to make sure that we don't think of just resetting it like that and introducing the fault as a way of determining it's safe, because you're going to damage it. And if you actually go too far with it, it will then kind of blow up.
That's why rewirable fuses are so much better.
Yeah. Yeah.
Not really.
So
Not really.
he's a little follow-up question on this. And so when using old MCBs, there's no way of providing a guarantee like you could with a brand new item. So maybe you've got an old 3871 or an old device.
All you can do is do a functional test on it, switch it on and switch it off, make sure it makes some breaks. That's as much as we can do.
He's brought up that dreaded term, the C50s. We had to connect into a C50 board. Yeah.
Yeah. Yeah. Yes.
All you need to do is whoever's providing you with a device, if you've got a device from a manufacturer, you want to obviously get that information. Now, if you're going to an existing board with an existing device that maybe is 30 years old,
probably more.
Would you connect onto that?
Yeah.
If you went into an old C50 board, would you put a brand new circuit onto that existing breaker, assuming it provides sufficient performance characteristics, or would you try to specify a brand new device?
The issue we got is that if the customer's asked for you to put a circuit in, and you then say, well, okay, I need to change the fuse board, I need to do this, that, and the other. If the customer says, well, I can't afford that, can't you just put another breaker onto there?
Well, no, not another breaker, but just using an existing one. Let's say you've got a C50 board.
Yeah.
You've got an existing C50 breaker that's available.
That's spare. It's available.
That's 30 years old, 40 years old, whatever.
Mm-hmm.
But obviously, you don't know. You know, the standard was made to technology enhancements and stuff. You know, there's going to be. You know, could you go on that? Would you say that's not really suitable, or we need something a bit more modern?
I think obviously most people would suggest to the customer that they get a new fuse board.
Mm.
But we're always in this situation where we can't force people to do things. So you can suggest and recommend. And if they didn't, I would actually have written out my risk assessment and stuff like that, and
would you point
my recommendations, and I'd get them to sign it to say that they decided against it.
Yeah.
You know?
So you would point it out, though, that you recognise that the device is of a prior generation and might not have the same, you know, characteristics.
Yeah, and the thing is, if it's an existing breaker,
bear in mind, we're not talking here about a VOE LCB or something that we don't use anymore. This is just another breaker.
Why not?
Yeah. Yeah, why not?
Yeah, but I mean, if it's an existing breaker that's been in the board, again, you don't know how much, you don't know what's happened to that prior to that.
Okay.
It might have been in use for a number of years, and it might have then been discontinued. Somebody might have done some other work, so you don't really know. Yeah, something that old, you would probably recommend, well, I would recommend a new board and this, that, and the other. But again, it's this thing, we can't force people to spend money. And so sometimes we have to do the best with what we've got. Now, remember, of course, that you're going to have to, if most circuits, you're going to end up putting an RCD on it as well. So,
yeah. All right. Sean says, regarding verification of resistance measurements of bonding conductors.
Yes.
You previously mentioned 200 milliamp continuity test might be sufficient to decide if pipe work could actually be considered as an extraneous part because it's under 22 or 23 KO. Mm-hmm. Where might there therefore be a need for IR testing to establish this? Now, I'm just thinking maybe when it's over the scale of your instrument. When might you need to up it to an IR test to verify if an extraneous insulation resistance? To verify if it's an extraneous conductive part or not. If you have continuity, you have continuity. But why would you go to an IR test?
You wouldn't.
You wouldn't.
No.
What if the resistance is beyond? Let's say you've got a meter that doesn't read that high.
Get one that does. Yeah. I think my tester reads to. I think mine actually reads to about 20. 20 kilo ohms. So my tester reads to 20, and basically what I do is if it's over that, then I just say, "Woof, okay, that's fine." You know, it's one of these, isn't it? We talk about the fact that your body resistance is 1,000 ohms. Well, sometimes it's more.
It's a very
You know?
generic term.
It's all a bit hairy-fairy, and so I must admit, what I've always done in the past is with my tester, it reads up to 20k ohms on continuity. If it's over that, then I
consider it not
basically say,
extraneous
right,
conductive part.
it's not an extraneous conductive part.
Yeah.
You know,
I can't
maybe
remember mine goes
people
up to,
might say, oh, you know, that's not quite right, but you know, that's how I've read it. Well, that's how I've applied it. Over 20k ohms, I would just say that's not extraneous.
Yeah, I mean, obviously, first of all, it depends on utilization for me. So, you know, what's the likelihood of access to that? I mean, we looked earlier on, we're in a switch room, and people are going, oh, this door frame into this switch room, you can touch the switch gear and the door frame. I was like, right. And I went outside, and the door frame, it actually is about 2 or 3 bricks up. So it's not in the ground, it's in the structure. So I'm okay. So it immediately doesn't look like it's in the foundation, so it's not picking up an earth there. But then there's a question if it's picking up a reference of earth through any of the other building elements. And that's where I would then throw an IR test, because you can touch quite easily that switchgear and that door frame. But a lot of people have just been doing I've seen so many of these little pigtail bonds. They're still being installed.
Yeah.
On things that don't move.
The only thing the thing I don't like about IR tests, obviously, is if you're touching onto metalwork, you're not quite sure where that metalwork's going and who's actually maybe in contact with it at the other end. So I'm always a bit iffy about doing insulation resistance testing on metalwork, you know, bonding and metal structures. But yeah, so I tend to just use my continuity tester. If it's over 20k ohms, then I call it as non-extraneous. Yeah.
It's okay. So yeah, he's just saying it was something mentioned by Paul and John. Did wonder whether it was the fact that it was the low test voltages being used. It's just relative to the instrument itself. I mean, the multimeter that has, you know, just a multimeter has a safer voltage naturally, but it makes no real difference to the actual resistance value that you measure at the end of the day. Okay. I'm going to scan through the chats to see if there's anything that's good. There's been lots of guys chatting their own little thing, which is good.
Good.
All right. And, during this,
that's what this is all about. Get people chatting.
During this webinar, Mr. Paul Meenan sat down. He brought me a Lucozade.
Oh, he's a little angel, isn't he?
And he's just disappeared downstairs. People have been saying hello to him. One guy asked about, obviously, and I'm going to ask you this because you're probably going to go,
what?
Soil resistivity.
Oh yeah.
I mean, I've done a little googly search, as I do when I'm clueless, and there are some specialists that obviously cover this at a point where you then select your cable naturally. Us as electricians, when we go to that table in the book and it says, you know, soil resistivity factors and stuff, I mean that's a designer table, isn't it? It's a designer requirement.
Yeah.
We don't have to consider that doing later EICRs. You think if you have a series of electrodes, maybe you've got a little electrode farm, and someone changes the soil's characteristics, do we have to think that far?
No.
Thank you.
It's the plain answer. Do you know what? We can do so much. We can go so far.
I picture myself as an ostrich with his head buried in the sand at that point. I'm like,
we can do so much, and we can go so far. Now, quite often there is things, as you and I do, we see things and think, oh, this is interesting, and we'll gen up on that and we'll read this, this and the other. Would we apply them practically? No.
I did a little digging.
Because it's just taking things a little bit too far sometimes.
Yeah,
you know?
I did a little digging. There are some companies that actually will go do tests, and they'll go to a laboratory and they'll do tests. And then there are some companies that use a little instrument that does tests.
Yeah.
But I don't see it being pushed into our remit.
No. At the end of the day, and we sort of touched on this the other day when we were talking about earth electrodes on generators. You know, if we're doing an earth electrode test, if we're just testing an earth electrode and doing the earth resistance test, it's a totally different test to an earth loop impedance test.
Yeah.
Remember that for fixed installations, when we've got an earth electrode, we've got the two options. We can do the earth electrode resistance test, or we can do the earth loop impedance test if we've got a supply. So we have the option of doing either. The earth loop impedance test will work because it will send a current through the ground or through whatever, okay, and we'll go back to the local transformer, and we will get a return path, and we'll get a reading. With measuring an earth electrode, like on a generator, that won't happen because it's not going anywhere. All the earth electrode is for there is just for reference. So it's two totally different tests. Now, an earth electrode resistance, so when you're testing soil resistance, they reckon is more accurate than doing an earth loop impedance test. But let's be honest, if you were working on a TT system and you've got a live supply, which test would you do?
Yeah.
And you know, I've got to hold my hand up and say, well, I'll do the earth loop impedance test because it's easier and it's quicker, and it saves me getting all them leads out and the probes. Yeah. So, you know, we've had to be guided by what we're doing, and obviously time and everything else. But yeah, unless I'm testing an earth electrode on a generator, that's the only time really that my earth electrode resistance tester comes out. It's a nice little walk in a sunny afternoon anyway, putting all those probes out and leads.
Another question here in the chat. Most basically saying he's new to testing. He's here to learn, which is great. Yeah. So he's got a beginner's question in his view. What's the best and most efficient way of IR testing line to neutral on an EICR or fault finding? Or do you have to remove loads such as lamps? So he's obviously seen that line to neutral is probably very often limbed. The IR test of line to neutral is often limbed. Is there a way to do it? Is there a quick way, a more efficient way? Or do we just need to remove the loads?
The only way to do line neutral testing on a circuit which has got loads connected is to disconnect the load. Yeah. Otherwise, you're gonna read through the loads. But you can also have a circuit with neons in it, in the spurs. You could have neon
in the lines themselves,
all sorts of things, photocells, all sorts of other stuff, and contacts, which will give you dodgy readings. Dimmers, even RCDs, anything like that will give you a down reading, give you dodgy readings. So doing a line neutral test on an EICR is quite often a long, laborious quest, because you've got an awful lot of disconnecting to do. And this is why guidance note 3
the worst thing is when you spend 2 or 3 hours preparing the circuit for that test, and then there's some freaking thing that's been hidden away that you still can't find.
Yeah, the classic one is the socket outlet that's behind the cupboard.
Yeah.
And they've run the cupboard lights off it.
Yeah, something like that.
Yeah, and it's got.
Sorry, you're saying guidance notes.
So if you look at guidance note 3, it does say that you know, if you're doing an EICR, for instance, then doing a line or a live conductor to earth test is suitable. You know, so we don't need to worry about doing line to neutral testing. We can just do a live conductor to earth test, and we have that. But that is a very important test, and for that we don't need to disconnect all the loads. So if you imagine if you were going to test Terminal 2 at Heathrow, right, and somebody said to you, well, you must do a line to neutral test, you're going to be there an awful long time, because you've got to take all them light fittings down, take all the lamps out, all the control gear, everything, right? Whereas if you want to do a live conductor to earth test, you can simply join the line and neutral conductors together and test those to the CPC or to the earth.
But does it mean, so is it too much? Is it so much of a problem that we're at the point where we just shelve the test idea, or should we try our best to do a line to neutral test if we can?
Again, it comes back to what circuit you're working on, what's the environment, what's the utilization, what environment you're in. If it's if you're working on a domestic property, it's not so much of a faff to go around and unplug things,
especially if it's void.
Yeah, especially if there's a void, it's not so much of a faff to go around and take lamps out.
Yeah.
You know? So you can then do a line neutral test, providing, of course, that you haven't got dimmers or photocells and things like that in place. Yeah, but you know, you're guided by the installation, and I mean, most of the tests we do, as you know, are on commercial industrial places, which are large, extensive. The idea of going around removing loads on those is pretty much a no-no.
A non-starter.
It's a total non-starter.
Yeah.
And that's why we do live to earth testing. And that's a very important test, and that is the one that's going to tell you or give you any indication if there's any cables going down to earth where there could be a possibility of perhaps somebody receiving electric shock because of a damaged cable. Yeah. So that's why that one is really, really, really important.
Yeah, I guess I mean, even leakage testing is not going to help you with a line to neutral insulation degradation.
No.
The only thing that could potentially help in the future when we start implementing them would be AFDDs, but that's relative to their suitable selection.
Yeah.
Yeah. Okay.
But that's and you know, going down that route as well. Remember, if you've got AFDDs and you've got SPDs and things like that, you've then got to think about those if you're going to do insulation resistance testing. You've got to look at removing those, and so you know, there's line to neutral testing.
And it needs to be mentioned.
Most of the time is something we do on EICs.
Yeah.
And when we get to an EICR, there's a minimal amount of that testing because of the faff of removing everything.
Yeah, and you've got to be careful because some manufacturers will claim that you can do some things that maybe you can't do.
Yeah.
One manufacturer is claiming that their MFT can test SPDs because the test operates at SPD. But we've done a lot of work, especially with E5, with the guys at Dane and Surge, and they're basically saying that's the SPD actually works at a much higher frequency to a much shorter duration of voltage that the instruments you're using to 1667 or whatever it is just output. So they don't output the same criteria. So they're really questioning it right now. You've got to be really careful.
Yeah. I mean, if he's new to testing, all right, read Guidance Note 3. It's a brilliant book. It's probably one of the best books the IET have written. Have a good read through that, and that's got a lot of guidance in it, especially the difference between EICs and EICRs, the way we approach them. Yeah, an EICR is completely different to an EIC, but an EICR has got to be approached by somebody who's got much more experience and knowledge about inspection and testing, because it's down to you then to make a assessment of the safety of the installation using the analysis of your inspection and test results.
Yeah. Phil just said also, doing EICRs for letting agents is impossible. They think they can tell us how much the job is worth. Yeah, we are gonna discuss this a lot. We're going to prepare for a webinar on this, but we agree.
We do.
There's a few guys doing a little petition going around Twitter at the moment.
Good.
There's lots of people who are passionate because they can see that this is going to be a huge downturn. We are very carefully trying to stay in good cooperation and a good relationship with some people. The NIC is because just before COVID we were going to start talking about things to do in the industry, try to help. And we're going to maintain good communications with them. But if they ask us, we're going to say that's shit if it is shit. So we're completely on point with that.
This is the thing, isn't it? Is the fact that some of the industry bodies like the NIC or the ECA or NAPIT may have a slight difference of opinion for various reasons. But the fact is that we need them people. Okay, we need those agencies and those bodies to get together with us, because we've got to fight this. This is just complete garbage.
They've got to. I said this in the video last year. They've got to kind of represent the industry, and the government's going to say to all the bodies that monitor or the assurances that help landlords will say, well, the government says go to those people, and so the NIC will be like, yeah, we're over here. NAPIT will do the same, and I go to our register. Just means more people can register, more schemes, more strategies. There are strategies. The NIC, I believe, have done. Approved contractors just need to submit to the strategy that the NIC are putting, which is okay. You must have this insurance. You must agree to this. It does say you will follow the advice of Best Practice Guide 4 for coding, which I disagree with completely. You shouldn't. That must be open. You shouldn't be like.
The Best Practice Guide was written by who?
Well, yeah.
I'm sorry, it's written by the Electrical Safety Council or whoever they are now. Electrical Safety First, who are part of the NIC.
Yeah, but the point is that that standard obviously gives us advice and guidance, but it shouldn't actually give us instruction. Like Codebreaker, they should not give us instruction. No. So as long as they're loose with that, they've worded it very poorly. And I am seeking some clarification. Anyway.
Non-biased advice is given by the IET.
Is that advice?
In most cases, yeah. Guidance Note 3.
Well, even that's crap.
Can be. But again, that's down to our own judgment. And where it goes wrong is that we are expecting to be spoon-fed the answer all the time. Yeah. rather than relying on our own common sense, our own knowledge, skills, and experience. And this is where the guys have got to sort of think and be confident with what they know and understand.
Yeah.
There's a lot of really good electricians out there. They know their job, they know what they're talking about, and then they're sort of given to second guess themselves because they hear other things from certain bodies. Rather than sticking to their guns and remaining with their principles, which are absolutely right, yeah, and they know what they're doing and they're doing the job correctly, okay, they're getting waylaid and second guessing and sort of doubting themselves because they're listening to all this other garbage.
Yeah.
Stick to your guns, guys. You know what you're talking about. You're bloody good at what you do. Carry on, and maintain your standards.
All right, I'm just going down the chat. I briefly mentioned TCW earlier on, and Sean's asked, if I can give a quick bit about what it does. TCW is the Compliance Workbook. It's Ryan's company. What it does is it takes certification of any format of PDF, and hopefully I'm getting this correct. The PDFs obviously they're layers of different information, and and then they're all stitched together. It pulls them apart and it sees what they are, and it then runs it through all the different requirements. So if you identify in your cert that it's a TT system, it's programmed to know that you should obviously have X amount of ZS values and X amount of behaviors, and you should have an electro as an ideal system. If you're a TNS, you shouldn't have more than 0.8, and it'll flag things like that. And if you say that your cable is this and it's this, and your ZS is this, and your ZE is this, and your R1 R2, it gives you some information. Now, it doesn't say wrong; it gives you information. So you scan, and it will make something red if it doesn't make common output sense with regards to resistances, with regards to arrangement, regards to just the use of it. And you can then choose to overrule it, to accept it, but it just flags it. And it all does it in seconds. And he's designed it for the social housing where there's thousands and thousands and thousands of these things being carried out, and with this legislation be more and more and more. And fundamentally, people who have all this document land on their system, they're going to have to pay someone to go through it all and check it. So the idea of it's a tool. That's all it is. It's not taking over that job, but you pump it through that, and it can then also, let's say, for example, you have one company that's got 12 engineers. It can show you that one or two particular engineers are doing many, many more, maybe too many in a day. One or two engineers are always getting it wrong with RCD tits, connection times or something. And it can pick up some common traits, which he can then give back to the managers of that business. That's kind of how it works. I already started working on something similar when I started doing my certification company. Pop knows about, Michael and I were working on CertFlex years ago. We're going to pick it up. The industry right now doesn't need it because we've got TCW, we've got Electroform, we've got companies doing the same thing. So, we're going to shelf it, but we're going to bring it back as part of a package with SparkyNinja later on when we've got the time. But I might end up, I've had a chat, I might even just use Ryan's tool if it works the way I want it to. But the way it works is you finish a cert, you've got a digital product, you can just hit a button and say, check this out, and it will then tell you, hang on, this is right or is this wrong? And it can let you look at it a second time. What a lot of guys do, especially guys who work for themselves, is they'll fill out a long cert and they'll do signed, and then the reviewed bit, they'll probably just do it at the same freaking time. I've seen guys hand over, multiple 100-page documents that were signed, completed, and reviewed on the same one day. And I said, so when did you take the time to review this? And they never really prove that they've done that, because when you look at something, it's always good to go off and do something else and then come back and look at it with a fresh head. Because so many times have you done something and then, later on, the next day, whatever, you've remembered something, you've looked at it and you've noticed it was wrong, but you've already signed it off, or you've already sent it off. So, these little things are what's needed, and this software can help with that. And we mentioned this earlier on, because if we had these numbers per day, if I had a guy pumping out 8 or so a day, I'd immediately have that flagged up. And I'd immediately go, right, well, I am approving him to do the work, so it's my responsibility to make sure he's doing it properly. And he's highlighted on my system, so I'm going to give him my time. And, actually, you're a bit of a dick, so I'm going to then cut him off. Simple. Yeah, and that's the idea of the license to practice model.
Yeah. Okay, yeah.
Okay.
It's interesting you say about that business about reviewing, because you know I've just been doing the ones for the sports stadium we've been at.
Yeah.
And I've done 73 test sheets so far, or sets of test sheets. I've got another 26 to do, and I've done exactly as you just said. You know, I've filled them in, I've gone away, I've come back, reread them, and because quite a few of the fuse boards are similar, yeah, I've actually cut and pasted certain aspects of it, yeah, and it's surprising how many times when I look at the actual sheets afterwards, dates are different, fuse board references are different, you know, and so yeah, to go back and review. I mean, obviously, I've put all the test results in as they were, but some of the information that I've cut and pasted, like
bits.
some of the faults and this, that, and the other, yeah, when I've gone through it, I've found out that I've sometimes haven't changed dates, I haven't changed disc board references. So if I'd have just banged those out and handed them over, I'd have looked a complete wally, if anybody had bothered to read them. But yeah, the idea of going away and then reviewing them afterwards with a fresh pair of eyes is really, really important. And also, it gives you time to sort of sit back and think about the test results and analyze the test results. And is this correct? Is this not correct? You can look at things and think, hang on, that's not quite right. This should be this, and you know that should be the same, and it's not. So yeah, it's really important.
So I'm just reading forward with the chat here, just seeing if I have access to a standard that was mentioned.
I need a haircut.
I can
see why you wear your beanie, mate.
Yeah, man.
I'm beginning to look like Doc Brown out of Back to the Future.
All right, so what's this? BS7430 is mentioned later on. Great counts and writes up. Generators, I think. Generator section. I don't know specifically what the standard is.
That's doing earthing, wasn't it?
Is that the one
earthing.
We looked at the other day?
Yeah, 7430 is to do with.
Did I send that to you the other day? Didn't I?
You did. You did send it to me the other day.
Oh,
it's to do with
I
earthing.
do have that. Apparently, there's a good section in there on generator. I think
there is. There is actually, yeah.
All
but
right.
again, it also mentions the fact that your main Earth terminal. It says in there that a main Earth terminal is very rarely at 0 volts.
No.
Because of different currents that are flowing through.
All right. Maybe we need to pick up generators and have another dedicated session on those. You know.
Which is why it's a good idea to link them together.
Yeah. Okay. Does TCW have its own certification software yet? Does it plan to? If not, when I last spoke to Ron about that, he said no, because it's an oversaturated market in his view. Which I understand. So he kind of sees his product as doing something more across other industries as well as just electrical. So he's trying to take that in compliance and risk assessment and control abroad, and he's not focusing on just another thing for the electrical industry. But it would work. This is the thing that I was thinking about integrating in mine. In the end, was integrating Ryan's into it, and we have had a chat about that over dinner a year ago. And that might work. If he doesn't have to do a certification, then I can probably use his tool and mine. Right. Okay. Okay. I think we all finished there.
Call it a night.
Call it a night on that. Thank you for coming, guys. Now, when are we back? We are back Saturday morning at 10 a.m. for a presentation. Now, I was supposed to be going home tonight, but I'm here another day because we've been to a depot this morning and done some work. So I'm not going to create a presentation or anything for Saturday. What I will do is I'll probably do a couple little things, and then I'll just get HSR 25 up, and we'll just talk through the regulations. So the idea of the one on Saturday is really just to talk about electricity at work regulations, a bit about its background, but mainly just go through the regulations, because we refer to EAWR a lot in our podcasts, in our talk, in our chat. I even have a course on the thing, not that I've used it much, but I just thought it'd be a good idea to talk about it, go through the regulations. We can talk about their relevance and scale. And I know after that, I think Paul Meenan is already working on a presentation where we're going to look at, okay, how can we link a relationship between EAWR and the fundamental principles of BS 7671. Because if we, as we code and go around, can go to a client and go, okay, yeah, fine, here's a code. If we go around and go, oh yeah, you know, non-compliant BS 7671 515 blah, 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 and just give them loads of regulation numbers, that doesn't help them in any way. We don't understand their need as a business. We just throw a load of our own observations and shit at them, and that doesn't help. So what we're going to try to do is look at, okay, how do those regulations translate to legislation? And how do those regulations in the main book relate to a fundamental principle at the beginning of the book in part 1, and therefore go to legislative work regulations? So we're going to bring all that together in a future webinar. But first, we need to talk about legislative work regulations themselves, and that's Saturday morning at 10 a.m.
Are we going to mention the Health and Safety at Work Act?
Yeah,
not,
can do.
Or
can
not?
do. You can do. It's just a case of keeping it quick. I don't want it to be.
Yeah.
Health and safety can always be like blah, 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 blah kind of thing, because there's not a lot of passion in it.
No, there isn't, and we forget about it completely.
When we forget about it.
And this is it's the same as with the electricity at work regulations.
Yeah.
You know, as you say, we go over it time and time and time again. Then when it comes to inspection and testing, we forget all about it.
Yeah, indeed.
Whereas a lot of things that we come up against in inspection and testing, if we forget or if we walk away from the regs for 5 minutes and we go back to basic principles of electricity at work regulations and health and safety, at work, then we would actually find guidance from them. This is something we've mentioned before.
Yeah, and if we can get to that point where we can actually say to our client, well, did you know that this actually means this legislation is a problem? They're going to listen a lot more.
Yes.
And they're going to want you to give them help to comply with those legislations.
Yeah.
And that's what we want to try to link. And it frustrates me that's not in the 2391, to be fair. But yeah, we're going to do that. Also coming up, we're going to do one on the private landlords, because that's a fun thing to talk about.
Oh, isn't it just?
We're going to talk about the 2396 design course on an upcoming webinar. These are all on SparkyNinja.com. You could already kind of tie on to them if you want to. We're going to do a couple of other ones as well for the guys who want the 8 p.m. slots that we've done before. But the 2396, we're going to go through the chief examiner report, look at the problems, look at the issues going on. If you've done a 2396, by all means, let us know what you thought about it. And we might look at running one if we think that we can run one in this format or in the future. But we want to just focus on what 2396 is about first and what's wrong with it, because how many people is it failing right now?
Last lot of tests, 70%. 70% failed.
So, yeah.
And going back over the last year or so nationally, it's normally between 50, 60, 70% failing. And
the funny thing is, we'll go through this in the webinar, but Phil read out a few of the things that are in there, and I've kind of thought, well, we've covered this in that podcast. We've covered this in this, and we've covered a lot of the issues that are failing many people. So we're going to look at those, and we're going to go, wow, that means we're probably okay and ready to do a 2396. And then we'll see what else we want to talk about, guys. I'm also thinking about doing a stream in a few weeks on a weekend, on a day, not on a Zoom, but maybe on a YouTube. And I'm thinking about just working on creating a model form. You've already started working on one, haven't you?
I've been here.
So I'm thinking about doing something like that. And so listen out for that. Lawrence, where can I share my thoughts? Well, you can either pop into the webinar that you did, that we're going to do when we do it, buddy. If not, are you on the Discord? If you can throw it in there. Because there's a design chat in there, I believe. Okay.
There is, yeah.
I
mean, as much as we can, we want to get other people involved. We want to listen to what you guys are thinking, what you guys are having problems with, and any issues you've got, and any comments you've got about anything to do with like 2396 or anything to do with inspection and testing, the temporary events, whatever, anything. Just chuck it our way. Or just chuck it around between you. The whole thing about this is getting people to talk, getting guys conversing.
Yeah,
and that's really important.
We've done a lot of talking, and across the podcasts, I've done a lot of talking, and lots of people have been listening. But now a lot of people are talking as well, and it's really nice.
Yes.
To kind of just be around people that, because we start learning as well that way. And I try to surround myself by people that I can always just sit and learn from. And you know, we're getting a great pool of people now that are just, yeah, it's a great group of people that we're kind of around right now, and it's great. Oh, okay. Terry said, "Are you planning on running the 7909? I can't even say this now. 7909D course anytime soon?"
Yes.
Yes, is the short and sweet answer to
The
that.
short and sweet answer to that one is yes. We've got a B course planned.
Monday, Tuesday, Wednesday.
Yes, 2 evenings next week. We've got a C course the week
following.
after, and we're looking at doing the D course after that.
Pretty much straight away after that, wasn't it?
So
yeah,
that
and
was,
obviously there's been some questions about the C course, the practical components. We are just at the moment, we're still right now in lockdown. We've only got a couple of sites right at the north and right down where you are where we could do them. But for us to do proper, say, right, let's get them done, we'd have to wait for the hotels or the booking meeting places to be more available for us to go around the country.
Yeah.
If that does take forever, we could do one in my area, the northeast, and in your area of Berkshire. We could arrange, but we're still just trying to buy time a little bit with.
There's also one of the guys
in Leicester
offered their facility in Leicester.
Yeah, and
So
I have a feeling some of the guys in Sheffield at Arena Train might be able to help me out if I want to go to Sheffield.
And we're more than happy to travel to come and do these. And we'll. The thing is, it's and I've always said this. It's easier for us to send a trainer to a venue where there's sort of 8 or 9 guys than it is for 8 or 9 guys to come and travel to us.
Yeah.
So we're more than happy to travel to you. And
so
if you've got the kit, great. If not, we'll bring it with us.
Probably once we've done this next C course, which is week after next, we're probably then going to have enough that when we look at what we've already do is go to them and say, right, geographically, it's like,
that's the one.
Where are you geographically? And then we can look at arranging dates.
Yeah,
because we know how many there are and where they are, and we can try and get it done.
Yeah, we'll dot them around the country so that it sort of minimises the amount of travelling that people have to do. Yeah.
George says, I'd like more info, etc. on the 2396, more on the side of doing the course itself. This is something we've been looking into ourselves because the 2396 is basically a 4-day course in a classroom environment. Information, do an exam, and then project.
Yeah, I mean,
I don't like it that way.
No, it's 30 hours guided learning. That's actually in the classroom, and then 100 hours total qualification time. So basically what it's saying is 30 hours of classroom time, and then 70 hours of you doing the project in your own time.
Indeed.
And what we're looking at is trying to arrange it so that we give you the design syllabus or the design sort of information and sort of help you with that, and then get you working, and then basically come back to us with your project. We can then go through it again, and we can rejig it, give some more advice, and then you go back and have another bit of time at it. And we're looking at, actually, we were throwing that around the ideas of doing this online, weren't we? We were thinking about doing maybe 3 days online or something.
Yeah, we were, because simply of geography and access to people who are interested. They're everywhere. And so we're going to look at a plan of doing a breakdown of maybe a couple of days and then a few evenings. But the project is great because once we get the project handed over, we can just do numbers of sessions like this, where we can just do open study sessions, and we can do them as meetings where we can get everybody on a camera and we can go, well, how would you do this? How would you do that? So it's something that we've been thinking a lot about. And
I'm actually currently working on putting it together. So
it was just a case of we wanted to make sure that we didn't fuck it up. And by that, I mean, we wanted to make sure that we could actually give you all the attention that you want from us.
We want it to be good.
Yeah.
We want it to be good. We want you to enjoy it, and we want you to learn from it.
It's not about passing the exam for us.
It's about knowing what you're doing and learning and engaging. Not just about getting you through exams. We want you to go away feeling that you've really benefited from it and you've enjoyed it and had a good time. And that's how we're trying to adapt it and build it. So, we'll put out some more information on it over the next couple of weeks.
And Lawrence, open meeting sessions would be brilliant. if there's any specific subjects you wanted to talk about, I can, in Discord, there's Discord servers, there's Discord voice chat. I can run something in there, and if there's enough people, we can go into a Zoom. I got no problem with any of this stuff being used to talk about anything you want to talk about, mate.
Absolutely.
And the training guys, on courses, we can do open in meetings as well. I had an 18th edition, and we were going to look at doing that. A couple of guys passed today. Company, which is good. A couple of companies have opened to do exam only options for them.
Yeah, that's the thing with the 2396. There is a dated entry exam on it, so there's only so many dates a year when you actually go in to do that dated entry exam, and we can run that at various places around the country again, but it has to be on a certain date.
Yeah.
So what we were probably thinking is that maybe you would do one up in the north and I'd do one in the south. And maybe we could get somebody else to invigilate one in the Midlands or something or other.
Yep. Or we can just
as a
change it around.
Gambit. So there's lots of flexibility with that. We just want to sort of try and make sure we get the right content and get the right delivery. So
Okay. All right, guys. It's 10 o'clock, so that's the 2 o'clock. Let's close this one. We are next. Are you coming on? You're coming on this one on Saturday morning.
I'll cut. Who's with you? You doing it with Paul, or you
just
do it with...
just me? I don't think Paul's on it. He's going to go on to the follow-up one.
No,
he might be on. He might come on. But yeah, okay.
It's 10 o'clock, isn't it?
10 o'clock in the morning, Saturday. Yeah. We're just going to talk about electric web regulations.
Yeah.
And anything else that we want to move forward. Okay, guys. Thank you for joining us this evening. I hope this has been interesting. I've got obviously Discord, Twitter, Instagram. If you want to message me about anything, or if you wanted us to do a webinar on any specific subject, let us know. And if we can work something out, we will. I've got a couple of ideas that one guy messaged me about doing webinars on, the filling in of the forms.
Yeah, can do.
A webinar on, how we decide how to approach different parts of the form.
You're sitting in the van making it up.
Yeah. we can
we do that.
We can knock them out. That's not a problem. Right, guys, have a good evening, and I'll see some of you maybe on Saturday morning. All right.
Take care.
Have a good evening. Have a good Friday. And see you later. Bye-bye.